So remember, whenever we do these, they're either going to give us something or we know something. That's what. So what I'm going to ask you, do we know something or did they give us something? So let's start with this number 1 right here. So when I look at 18, I notice that they gave me 3 and they gave me 5. Well, I can't really rewrite 18 as a 3 squared. Well, 3 squared is 9. 3 to the third is 27. Well, and 5 doesn't go into 18. So I might have to think of it in a different way. And in the different way, I probably will have to think about it as a multiplication problem. And whenever you do a multiplication problem, you guys, I want you to think of a prime factorization. So basically, what is the prime factorization for 18? And what I mean by that is if we drew a tree, right? I have 2 times 9. 2 is and then 3 and 3. So I can break that. I can break up log base 4 of 18 into log base 4 of 2 times 3 squared. So even though I couldn't break it down so that it had a base of 3, I kind of broke it down into a multiplication problem. Now that rule that we learned is, this is a multiplication problem, so we're going to rewrite it. Log of base 4 of 2 plus log of base 4 of 3 squared. Now, log of 4 of 2, they didn't give us, right? They didn't give us log base 4 of 2. So that must be something we know. You guys, so if they didn't give it to you, it must be something we know. And let me show you how we know it. How could we change this to exponential form? So here we go. Just a reminder. What's the base? So I'm only looking at this part. What's the base? What's my exponent? Or y is fine. And what does it equal? Okay. How can I rewrite 4 so it has a base of 2? What is it? 2 squared, and then I put the x on it, equals 2. So now I have 2x, because I'm going to set the exponents equal to each other. What does x equal? 1/2, right? Sorry, people. There we go. So that means log base 4 of 2 is 0.5. We're going to change that to a decimal. So that's this one. Now this one, log of base 4 of 3. Well, they only gave us log of base 4 of 3. So what am I going to do with that 2? Where does that 2 go? In front. So now I have this. So it is going to take a little bit. Like, you guys are going to have to kind of think. Now, is log base 4 of 3 something I know or something they gave me? They gave me. So I'm going to put 2 times 0.7925. Again, they gave me this. I'm going to multiply that. And when you multiply that, what do you get? What is it? 1.585. Now I can add those, and what do I get? Is it 2.085, I think?
Yes.
So we did all of that to get this answer. That's a longer one. I'm sorry that I didn't make more room for you in the box. But that is example 1, okay? So again, you guys, I'm just going to zoom out really quick here. This right here, log base 4 of 18 equals 2.085. So we did all of that to get this answer. Okay? They're not all going to be that long, but they could be. Okay, number 2. Can we change 15 so it's just a 3 or just a 5? We can't, but we can do a prime factorization and get 3 times 5. Okay, so now what we're going to do is, this is a multiplication problem. So how can we rewrite, how can we make a multiplication problem work for us? We can change it to addition. So we would have log base 4 of 3 plus log base 4 of 5. So all I did was take the multiplication problem and split it up. Now, here's my question. Log base 4 of 3. Do we know that, or did they give us something? They gave us 0.7925. So we are going to write 0.7925. So log of base 4 of 5. Do we know that, or did they give us something? They gave us something in the problem. So when you do these, you guys, you always have to ask yourself, do I know that, or did they give it to us? There's 2 ways for you to know it. One, like we just did, where you have to put it in exponential form and do it yourself, or you just know it, like log base 4 of 4. And then what did we get for our answer? We're going to add these 2, and what do we get? Okay, what questions do you have? So you guys, 15 didn't break down, so I broke it down into a multiplication problem. Sometimes that's what you have to do. If you can't rewrite it as a solitary base, then you'll break it up into a multiplication problem. Okay, let's look at example 3. Is this, this is a division problem. Oh, and I want to tell you guys, see that 4? It's not log 4 and 5/3. That's log base 4 of 5 and 3. So it's a division problem. So you guys, most of the time when you see a division problem, you're going to have to rewrite it. So we're going to write it as a subtraction problem. So log base 4 of 5 minus log base 4 of 3. So how did I know to do that? Because it was a subtraction, it was a division problem, and there is no way. Like 5 and 3, like, you're not going to be able to write that. Now, if it was 6 over 3, you guys, you might be able to write it. Okay, now, did they give us something, log base 4 of 5, or do we know that? They gave it to us, and that would be 1.1610 log base 4 of 3. Did they give that to us, or do we know that? They gave it to us in the problem. And now let's subtract. Okay, so subtracting, you got 0.3685. What questions do you have? Okay. Number 4. So again, you guys, that 4 is supposed to be a base. Can you reduce 3/4? Can you rewrite it? So we're going to, and what I mean by rewrite it, like, can we write it as a base? No. So we're going to split it up. It's a division problem. So I'm going to rewrite it as a subtraction problem. Log base 4 of 3 minus log base 4 of 4. Now, you guys, you can do this with, you could probably do this when you're, when that number is a fraction. But you have to, you kind of have to know what it equals to. Okay, so now, log base 4 of 3. Is it something we know or is it something they gave us? It's something they gave us, and it is 0.7925 minus log of base 4 of 4. Is that something they gave us or something we should know? We should know, and we talked about it yesterday. Do you remember this? That when the base and when these two numbers are the same, what does it equal?
1.
And now subtract those. And tell me what you guys get.
-0.2075.
Perfect.